things straight up. Well, how are we doing this morning? We doing that good? About that good? All right. Hold on 1 second here. So what are you working on this morning? What can I help you guys with? Have we discussed whether or not you guys want a chapter 8 test and final, or just a final? Came up a little bit last week, but we just come to a hard conclusion on that?
Hey, Matt.
Yeah.
Are we gonna have 8.4 and 8.5 on the chapter 8 test?
No.
I'm sorry?
No.
Oh, okay. You were cutting out, my bad.
No problem. Chapter 8 is 8.1 through 8.3. I know we talked on Monday, 8.4 and 8.5 were kind of bonus sections. So they are good stuff. There's stuff that will come up, particularly if you go through calculus. 8.5 is really on polar coordinates is really is stuff you'll do sooner and use more often, particularly if you're going into any kind of work with graphics, and some work in physics, but the 8.4 on parametric, if you plan on going heavy into your mathematics, you'll use parametrics a lot. But we do parametrics again and polar again when you get to Calc 3. So not only will you use those in Calc 3, but you'll go over them in Calc 3. They're certainly a good thing. If you know you're going to go through the full calculus series, they're a good thing to look at. But I won't have them on the final or your chapter 8 test if we do both a chapter 8 test and a final. Though if you guys wanted to, we could put a little bit of the polar stuff onto a final if we just did a final.
So I already took the chapter 8 test like 3 days ago, or I think it was 3 days ago. Are you still deciding if it was just going to be just chapter 8 or if it was going to be a final in addition?
We discussed it. It came up a little bit on Monday.
Okay.
And somebody was asking me about it during the break. Sometimes we do, sometimes we don't do both. I don't really have a strong preference against it. Mostly just as that chapter 8 being kind of a preview for your final stuff so you can practice. How did that chapter 8
It
go?
was fine. It was fine. I had gotten through 8.4 and 8.5 pretty
Right.
quickly. There was one question like going from polar to Cartesian, or no,
Mhm.
it's Cartesian to polar, I think. But yeah, that was fine. I was more worried about an accumulative final just because I'd have to go and review the past 3 chapters. So I wanted to know if that's how I'm going to be studying this week. I also have to study for physics.
Yes.
So that's what I was worried about, was knowing whether or not I needed to go back and do those reviews again.
You do. A lot of the final is 8, and or 8 without the 8.4, 8.5. But you'll find most of the stuff that you go back and review, particularly from chapter 6, is stuff that we now use day in, day out.
Yeah. I was more worried. I think the only thing I was worried about were back when we were graphing with the amplitude and all that. I needed to review that section again.
Yeah. And the
think
2 things you'll find that on the final that are important to review, graphing is generally one of them.
Okay.
And graphing is an important thing to review, particularly before you go into your physics section on light and electricity, because the aspects of those functions come into play pretty heavy in there.
Gotcha.
But also the little section we had on linear versus rotational speed.
Yeah, I caught that. That was helpful. We were a little bit behind. Physics, we did everything a lot sooner than we did. We started vectors first week physics, and it was so
Mhm.
now it made it easier for math.
Oh yeah.
But okay, yeah.
Are you doing the physics with calculus or
No, I
no?
don't need
Okay.
I just needed the algebra for my biology degree.
Gotcha. Okay.
No, so this was a co-requisite for that.
Right. So yeah, by then the language of vectors would have been secondhand.
Mm-hmm. All right.
So why don't we do this? Let's make the chapter 8 test essentially I'm going to call it a bonus test. So what that means is, if you want, take the little chapter test and keep that current score, keep total score. So if you did good on your 6-7 test and you do good on the 8 test and your score is nice and pretty, or something that you're satisfied with, then great, leave it. And then have an optional cumulative final that can boost final scores. And I'll put a caveat here, will not lower scores. So if everything's been going fine and you want to take one test, that will include the 8.4, 8.5. But as you said, the 8.4, 8.5 there is not bad. But if you want to just if you want, you can take that chapter 8 and then keep your score after that. If you don't want to do chapter 8, you can just do the final with or without chapter 8. So your paths, you can do, we'll give you a lot of choices here. You can do just chapter 8 and take your current score from that. You can do just the final and take that total. Or you can do chapter 8 and get a boost from final.
So will the final have the cumulative final? Will it have 8.4 and 8.5 as well?
No. So if you're really like, because finals can be a lot depending on how many classes you have and how much is going on. So doing just the final, you would not need 8.4 and 8.5. And that would be the kind of like, I'm stressed for time and need to reduce my like workload right now. The just chapter 8 is some reduced workload, everything's gone fine. You don't need the final. Like, you were saying, you've done everything else. You're just managing your time between your final and physics.
Yeah.
If the 6, 7, and 8 stuff was all great and you're happy with where your kind of current score stuff is, then you can just focus on physics.
Okay. Were you going to have the grades for this 7 and 8 up? Oops.
I checked 7 this morning. I thought you guys could see 7, and it looks like somebody said they couldn't see it. I went and messed with it some more. But
I checked before I hopped on and I wasn't able to.
Okay.
Oh, yes. No, it's up now.
Okay.
Sorry. It must have been right before.
And then if you either are concerned about some of your other scores and or have lots of good time this week, you can do the chapter 8 and then do the cumulative final only a boost. So the cumulative final, if you do 8, the cumulative final can add but won't take away.
Awesome. Sounds good. Thank you.
They got all kinds of choices there.
So does 8 count towards your grade 2, or is it just like for practice?
If you can do it for practice. You don't have to do 8. If you take option 2 here, then you can not do 8 and just do that final, and you're fine. If you want to do 8 and then do that final as a boost, then if 8 doesn't go well, I can replace it with the final. So it's just practice. And if you just want to do 8, you can just do 8.
Okay, thank you.
Sure. That way you guys can, depending on what kind of time you have and what kind of stress levels you are at.
Matt, so the chapter 8 test is due tomorrow. Is that going to be pushed back at all, or is that set in stone?
I could push that back too if you want.
I'm
I'd
only
rather
asking
not
because-
push that back to Thursday, though. I'd rather push it to Wednesday. Is that sufficient for your purposes?
Yeah, I just wanted enough time to practice 8.3 and or 4 and 5. Sorry.
Fair.
Thank you.
Hold on one second. Okay, let me go in and change that. What is it? Chapter 8. Where are you, chapter 8? Oh, there you are. So instead of the first, that on the second. Okay. Well, I'll have to move that too. Okay, move that to the second. And then the final still on that Thursday, for those of you who want to take the final. And that way, anybody who's not checking in with the stuff we're doing here will just have 8 and final, and that won't hurt them in any way. It'll actually help them. Okay. Questions about it? Any of that? Is that helpful?
Yes, that was helpful. Thank you so much.
Okay, good, good. Anything material-wise you want to look at? Looking over most of your guys' overall scores, you guys have been doing really well so far. I attribute that to you guys keeping up. Helps a lot. Let me modify that chapter 8 so it shows you scores automatically. I really don't like this whole you guys can't see stuff until later thing. Students can view correct answers after due. Okay. Okay, hopefully that setting will allow you guys to see your chapter 8 stuff immediately in case you got to make some decisions. If not, let me know. So is there anything from 4 or 5 you want to look at? Or anything from 8.3 you want to look at? I know there's a couple of you, some of you are still working on that 8.3. You said there was one problem going from, what was it, polar to Cartesian, which is generally the harder of the 2 directions to go.
There were a couple from 8.3 that I needed help on. There was one that was question number 14 on 8.3.
Number 14, you said?
Yeah,
Okay.
14, 17.
So if I'm looking at the right 14, person leaves home, so we can say home is our origin, walks 2 miles west, so 2 miles west, and 3 miles southwest. So they go 2 miles in this way and southwest. So what direction is southwest? So that's west. That's south on our scale, if we make that north. So southwest is defined as being directly in between those. So it's that kind of halfway point, that 45 degrees. So that means they've then gone this way at 45 degrees. Fair? And sometimes that's the issue with this question, is like southwest. What's southwest supposed to? It is actually a technical definition. You might have heard of things like, south by southwest. So south by southwest bisects that. South by southwest bisects that and is 12.5 degrees from there, in case you're curious. So we've gone that way 2 miles and this way 3 miles. How far from home are we? Well, how far from home is going to be that distance. So we want to find this distance. And what direction must we head to go directly home? So we will need this kind of angle here, and we'll probably want to find it from north. So that angle there, or some reference angle in there somewhere. Does that seem like a reasonable setup? I drew that at the wrong side. Makes it hard to see. So that's 3. And then I'd probably want to know that angle from north. So that's our setup, our diagram. Does that diagram work for you, Kate?
Yeah.
Okay. So if we want this distance, we know this interior angle for that triangle is 135 degrees. So we can find that distance with just a little bit of law of cosines if we wanted to. We could also take this vector and that vector and add them together. The magnitude of that vector is going to be that result, distance d. So we could do this as a law of cosines question if we wanted to, or we could do it as a vector adding problem if we wanted to. Do you have any preference? It's our section on vectors. We might as well do it with vectors, right? So let's do it with vectors. So this first vector is, well, it depends on how we want to measure it. Got a lot of choices here. That vector is a vector magnitude 2 going in that direction. So if we wanted to measure everything here from standard position, that vector would be going at pi radians in standard position if we wanted to measure it from standard position. We could also say it has an angle of 0 from north method measured in that direction, or we could say it has an angle of, lots of choices here, an angle of 270 measured in our kind of navigation direction from north. So what do you want to consider its angle? Do you want to consider its angle to be measured from standard position, measured counterclockwise from north, or measured clockwise from north? Either of those choices are fine. Do you have a preference?
No.
No. I tend to either go with standard position because we do a lot of things from standard position, or I go from measuring from north because it's a navigation based question. And we do a lot of navigation from north. And it really doesn't matter which. Let's go from standard position. So from standard position, this first vector we could say has a magnitude of 2 and is going cosine of, I should do it in degrees, I suppose. Cosine of 180 degrees in your I and sine of 180 degrees in your J. If you're doing IJ form, if you're doing the position vector form, then you'd write it like that. Cosine of 180 degrees is, of course, -1, and sine of 180 degrees is 0. So that becomes the vector -2, 0, which should seem reasonable. It went in the negative x direction too, so -2 and up nothing. Fair? Then we go down this way. So we got to define that vector. That vector has a magnitude of 3. So I want it to be magnitude 3. What direction is it going from standard position? From standard position, that angle would be -135. So cosine -135 degrees and sine of -135 degrees. Now I have that magnitude out there. You guys, of course, are happy with your r cosine theta, r sine theta, right? I'm doing the what's often referred to as the trigonometric form, magnitude times direction. But whichever form you like, I'm distributing that r anyway. Fair? One of the things you'll find with vectors is there's a lot of choices in how to denote it. You know, you have been doing physics, you've probably been doing them a lot as column vectors, right? So, and same thing, it's just up and down instead of left and right. So lots of different ways you could handle the vector. Again, nice thing. We know the cosine of 135 is the square root of 2 over 2, negative. And the sine of -135 is negative square root of 2 over 2. It's on our unit circle even. Times 3. So -3 square root of 2 over 2 and -3 square root of 2 over 2. So that's our green vector. So that's our green vector. That's our blue vector. Cade, you happy with that so far?
Yeah.
Okay. So what's our overall movement? Well, we be adding those two vectors together. So our overall movement, our what will point to our ending position is going to be their sum. So it's going to be the u plus the v. I forgot my arrows. I feel bad. So -2, 0, plus 3 square root of, no, yeah, 2. 2 over 2, negative, and -3 square root of 2 over 2. So -2 plus 3 square root of 2 over 2. I pulled that negative all the way out for almost no particular reason. And then negative 3 square root of 2 over 2. So that's that resultant vector. That fair? So if we want to know how far that is, we got to find the magnitude of that vector. Now it's going to be some irrational value with all these things, but we know how to find the magnitude of a vector. It's the square root of the sum of the squares, just a little Pythagorean theorem. So negative 2 plus 3 square root of 2 over 2. Make sure that negative is all the way out of that or distributed in, doesn't matter. Squared plus negative 3 square root of 2 over 2 squared. And that's going to be some value. I don't know what that value is. We could FOIL that all out and get an exact answer if you wanted to, or get a decimal approximation with your calculator. You want to get a decimal approximation with that calculator? Or an exact value? Exact value would take a while, but it's okay. It's fun. I don't have a preference. You guys have a preference? I will take the silence as no preference. Decimal approximation it is. Cool. Cynthia, you got that brow thing going. Is there a question behind that, or just brows do that sometimes?
Oh, no, I was just making faces at it.
Okay.
It's okay.
Cade, what about you? You happy with that?
Yep, I'm good for now.
Okay. So that's our distance. We then need that angle that we'd have to go back from port. So, you know, the way I've drawn it down here, it's this kind of angle here that we'd have to go at to get back. But does it seem reasonable that this angle is the same measure as that angle? Well, not the same measure as that angle, but that those should be related to each other. This angle would technically be the same as that angle, right? So if we want this angle, oops, that was messy. So if we want this green angle here, we could get that by finding this angle here. Does that seem reasonable? Those green angles have to be the same. So if I want to know from this location, you know, what did I do? I walked from my location where I walked over this far and then down that far. From this location, what direction do I have to turn to make sure I go directly home? So we're going to find that by finding that angle, because they have to be the same. Cool. Okay, so how do we find that angle? Well, we know this vector for D. That vector for D is down here. And we know the tangent of that angle has to be the ratio between those two pieces. The tangent of that angle, we essentially have that position, that negative square root of 3 square root of 2 over 2 over the -2 plus the square root of 2, 3 square root of 2 over 2. That's got to be the tangent of this angle. Or if you prefer that angle, it's the same tangent. So we at some point want a tan inverse of this. So anybody who want to tell me what the tan inverse of 3 square root of 2 over 2 plus 3 square root of 2 is? I canceled out those negatives and canceled out those 2's.
Um, 34.2009.
Anybody want to back that up? Now, you know that's just one angle, right? You know there are technically 2 angles, right? There's that angle at 34.2 degrees, right? And that's the positive angle that you were given. But then there's the one that faces down this way in the direction we want to go, right? And that would be this pink one. And that pink one would be what, 146.8. Negative, of course. Is that fair? Ease navigation, kind of that angle direction is always a tough question because it's like, well, what am I measuring it with respect to? You know, because that's, you know, degrees heading south from west. That's a weird way to measure it. This angle here, we'd have to take 90 away from this. So that would be this angle that we were kind of looking for here, that green one would be 90 less than that. So that would be what, 56.8 degrees. So that's face north, go 56.8 degrees east. So that would be north, or how much east of north. If you want to measure it from east to north, like, you know, face east, and how much do I turn towards the north? Well, if that's green one there is 56.8 degrees, then what's left down here? What's left down there would be what, to make 90? Would be what, 24.8? No, 24.2. So like, which one of those do you want? Depends on which way you're measuring. So 24.2 degrees north of east, or 56.8 degrees west of north. Or if you want to, we could keep going from north this way. Okay, would be what, 90 plus the 24, so 114.2 degrees east of north. So those are always tough. Like, what does it want in terms of the direction it's giving? Because there's a lot of slightly different answers depending on what your reference is. And if that lady who had been doing physics was still here, she'd tell you one of the things you do in physics is you define, I'm measuring everything from this direction, or I'm measuring everything from that direction. And then all of those answers are to the same scale, you know? But which one of those you want to use depends on your frame of reference. So, Kay, that's not a hard, fast answer, but does that make sense on how you approach finding that angle?
Yes.
As I said, we could have used law of cosines to find that raw distance, but we really need the vectors to find that angle. So why do all this when we just need that, raw distance? I wouldn't do all that if you just need that raw distance. I just use law of cosines. But since we need to find that angle, we really need other vectors to help that. And this question, as I recall, is a little bit vague on which direction it wants, like which way it wants it measured from. And I think it can take a lot of different answers depending on what direction you want to use. On things like your final, I make sure how many degrees measured this way. So I'm always very specific on what direction I want. Because you could technically give answers like so many degrees off of so many other degrees, or you turn, how many degrees you turn from your old path. Like if you're facing this direction, which is where that's 45 degrees, how much do you turn from that direction to be heading in that direction? You can give any of those answers. As soon as you know any one of these angles we're talking about, you can walk yourself around to any of the other angles. If that's supposed to be 45 and that's supposed to be 34, you could certainly figure out what that angle is. So you can build any angle you want, as long as your axes are at 90 degrees to each other. You can build anything. I might have over answered that question. You then said you also were looking at 17?
Yeah.
Oh, 17's fun. So, and almost has another law of cosines if you wanted to answer. So we have one vector 0, 5. for the vector 0, 5. And another vector -1, -2. So -1, -2. -1, -2. And we're asked for that angle between them, right? Now, if we wanted to, again, angle between them, you remember law of cosines does give you a way to find angle between things, right? So we could use law of cosines. To do that, we would need, though, to know these distances, which we could find, it's those magnitudes, and this angle, or this angle, whichever one we wanted. So we could determine that big angle using a little bit of law of cosines, but we'd also have to find this angle between there. That's all kind of irritating. But we could do that. Now, I'm really stuck on the fact that this is straight up, right? Could we rotate this problem to that being 0, 5? I don't want to do that. What tool do you want to bring to this problem? There's lots of ways we could do it. So we could do law of cosines, but it would be a long trek, right? You've read through your section on dot products, right? And remember that dot product gave us the value that you would get if you multiplied the magnitudes together, but lessened by the cosine of the angle between them, right? So, for example, if you had two vectors, one magnitude 5, the other magnitude 4, and you took their dot product would be 20 if they point in the same direction, right? If they point in different directions, that dot product would be less than 20. If they point in exactly opposite directions, that dot product is -20, right? So our dot product essentially gives us product of our magnitudes, but modified by, lessened by the efficiency of how well these two things are working together. So that was your definition 1 for how to find a dot product. But you also looked at how to find a dot product in just component forms. You took the first components, their product, and added the second components, their product. Right? And that's just multiplying. If you take U1, U2, sorry, I labeled that wrong. I said it right, but I labeled it wrong. U1, V1, U2, V2. If you multiply dot product these two vectors together, you're going to FOIL, right? So the first times the first, U1, V1, those are going in the same direction, right? Because they're both essentially the X direction. Then U1 times V2 is 0 because they're heading in opposite directions, or orthogonal directions, perpendicular. U2 and V1, their product also 0 because those things are orthogonal. And then U2, V2, those are parallel in the upward direction. So same direction, so it's just their product. Good old multiplication with a dot product idea in there. You guys read all that, right? Yes, no, maybe. I got a yes. Kate, you saw all that, right?
Yes.
Okay, good. So this is a nice tool for finding the angle between things. If we can find the dot product of these two vectors, 0, 5, dotted with -1, -2, using the component form, that's going to be 0 plus -10. So that's going to be -10, which should seem reasonable because they're going against each other. They're headed in kind of opposite directions. So it's a negative value. That -10 should equal the product of their magnitudes. So we'll have to find their magnitudes times the cosine of the angle between them. And we want that angle between them. So the magnitude of the first vector is just 5. That one's easy. Magnitude of the second one is going to be the square root of -1 squared plus -2 squared times the cosine of that angle. So -10, 5 square root of, is that just going to be 5? That's kind of cool. Cosine theta. So -10 divided by 5 square root of 5 equals cosine of that angle. Or if you want, -2 over square root of 5 equals the cosine of that angle. Okay, is that all good so far?
Yes.
Cool. So then we just need a cosine inverse of the -2 over the square root of 5. What is the cosine inverse of 2 over the square root of 5?
I got 113.58.
And it's a trig inverse, so we get 2 answers, right?
Actually, hold on. I forgot to do the square root of the 5.
Oh, okay.
Yeah, I think that will change the answer for sure.
Yeah, it's pretty close to -1, so that's going to be on the large side.
I got 2.68 rounded up.
2.68, you're of course in radians,
No, you're
which
right.
is fine.
Yeah.
But why don't we do this in degrees, since this section likes degrees a lot more.
Okay, so I did it again, and I got 153.43.
That sounds more reasonable. So there's nothing wrong in this problem with radians. This particular question does ask for degrees. But of course, you do get 2 answers, right?
Mm-hmm.
The other answer would be what, 207.57 degrees? Now, why are there 2 answers? Well, one, it's an inverse function. There are always 2 answers, right? Right.
Mm-hmm.
In the first rotation. Do both answers make sense? Well, they should. That angle there is 153.4 degrees. This angle here is 207.6 degrees.
Oh,
Both, and like, well, what about all those coterminals? Well, what if you went around and then to there? Well, that's, the plus 360K. All those answers are in this problem. Fair? But which one are we looking for when we talk about the angle between things? It's that smaller angle. So the 153.4 is the answer that we want. But I like to remind you guys that one, anytime you use a trig inverse, you get two answers and all the coterminals, right? Don't forget that. But it's nice to have a very clear, oh, here's what those answers even represent in this problem. Fair? Because depending on the application, depending on why you wanted to know the angles, you might want that other one for whatever reason.
Oh. Everything's kinda-
Isn't that neat?
Yes.
So, okay, because the dot product, essentially what the dot product does is it gives us product of the magnitude reduced by the cosine of the angle between them. It's a nice way to find angles between things, because you essentially look at, well, this is what the product of the magnitudes is what the product is supposed to be in an ideal scenario. The dot product is how much the magnitude or how much the product is in the reduced scenario when they've been affected by their angles. So you want to find the angle between those. Well, find their ratio. That ratio is the cosine ratio. That make sense, Kate?
Yeah. Thank you.
And yeah, dot product and cross product later is used a lot in physics, because you've got a lot of things where, you know, if these two things were headed in exactly the same direction, we know what would happen, but they're not headed the same direction. One's going this way, one's going that way. Well, how are they going to affect each other? Dot product instead of normal multiplication, or what we think of as normal multiplication. Anything else I can help you with today?
No, I think that's good.
Okay. You can bring stuff on parametrics and polar on Wednesday if you want to talk about that before you take that 8 test. I will tend to focus more on polar
Okay.
on that 8 test than parametric. By a reasonably high degree. But the reason your textbook goes parametric and then polar is because technically polar is a type of parametric.
Okay.
So it's like, here's what parametric is really briefly, and then, hey, here's how cool polar is, because polar is actually really cool. But parametric is a very, very broad set of tools, of which parametric is the trig-based one.
Okay. All right. Thank you.
Sure. Kate, you good?
Yep, I'm good for now.
Okay. Cynthia, anything you need?
Nope, I'm good right now.
Okay.
Thank you.
Yep. Talk to you guys later.
All right. Bye. Have a good day.
Bye.